Going over the evens for homework, we just did number 4, walk through the solution. That's what you guys should have gotten. Number 10, let's stop all the annoying noises. We have a test tomorrow, and I don't know about you guys, I cannot agree. So, question. How do I graph y equals mx plus b? It's a line. What's the intercept if nobody's there? 0. So I'm going to put a point at 0, 0, and my slopes, what am I going to do? Up 1 over 2. So, up 1 over 2. Up 1 over 2. I can go back 1. Sorry, down 1, back 2. Anyway, long story short, I have my line. Now, wait a minute. Don't they give you some restrictions? They say x equals 6 and negative 6. Well, stink, I need a few more points. I have 4, 2 points, 6. I need to go 1 more up and over. And I need to go 6 the other way. So I'm at negative 2. Let's go negative 4. And then let's go negative 6. Now let's go ahead and form that line. And we're stopping at when x is 6, and we're stopping at when x is negative 6. Now, where are we supposed to be spinning this thing around? Do you want to visualize this last night?
Double cone?
Yeah, it's a double-naped cone, kind of like the conic sections where they came from. It's one of those cones, with the little slices cut out of it, but 2 of them. So when you spin it, you just need to follow this rotation, and this one's going to follow the rotation as well. So long story short, you end up with it's not perfect in sensitive perspective, but it's the idea. If you understand the, of course, it can be. But there we have our double. And it's kind of nice because they did tell you cone formed by, so they gave you a hint. They didn't tell you it's a double named cone. All right. Any other questions besides number 11 from homework on the odds? Because that was number 4, that was number 10. The rest were odds.
11.
Okay, so we're just going to 11. All right, let's go to 11. If I were you guys, I'd grab out your calculators. There's going to be one of these on tomorrow's test. Just one, not like number 13 or 17, but like number 11. It might be a little bit closer to the example we did in class. We have to put a triangle inside a parabola. Well, the first thing is we got to do graph, right? Didn't we talk about yesterday for an earlier question, getting the graph of 9 minus x squared? Yeah, I think it was the first example that we did yesterday, not the day before, but yesterday. So 9 minus x squared, wouldn't that be a parabola that's just been shifted up 9?
Yeah.
And then we talked about yesterday how it's going to hit positive 3 and negative 3. So we have our parabola. Up, let's see how it says, and the x-axis, so it's not going to go below the x-axis. It's just going to hit. What are they telling us to fit inside this parabola?
Triangle.
The triangle. The vertex of the triangle is at the origin. Oh, the vertex is the point of the triangle, right? So it comes to a point at the origin and it hits, I don't know, somewhere. Now guys, this is not necessarily the perfect triangle. I just made it up. It's a triangle that's inscribed within. Okay? It's not necessarily the perfect one. It's a representative triangle to give us an idea. So when we're doing these problems, the very first thing is get our pieces. So we got our parabola, bounded by parabola on the x-axis. We just put in our triangle coming to a point at the origin, hitting somewhere. Don't go counting tick marks. I'm not saying this is the perfect biggest triangle. But we do know that it hits at an x and at a y. And we're going to need to use that because it says maximize the area, I think, right? The maximum, oh, they gave you a picture. You guys see the picture on the other side? Yes, anyway, we're trying to find the maximum area. How do you find area of the triangle? Now the struggle is getting a base in terms of x and a height in terms of x. So let's go ahead and come down here and let me say, to any point, the distance over is the x, and the distance up is the y. Okay, now if I want the base of my triangle, and if I want the height of my triangle, can anybody see how we can relate x's and y's with b and h?
2x.
Good. 2 x's will comprise the base, and then what's going to comprise the height? Just 1 y. So I draw this little x and y in order to help me out with base and height. So 2 x's will make the base, 1 y will make the height. Let's go over to our formula and plug that in. So I have 2x being the base, 1 y being the height. Now we want to put this into our calculator, remember from yesterday, and we want to find the maximum using our calculator. But the dilemma is, there are too many variables. Our calculator doesn't let us put into the graphing window 1/2 times 2x times y. That's not a thing. That's not allowed. I can only put in like a variable equals and then an equation in terms of the other variable. So how on earth am I going to get rid of this y?
Divide by y.
Don't divide by y, because I still have too many variables.
Oh.
I go looking for who is y. Not a clue right above. He was just waiting to be plugged in. He was just waiting to be plugged in. We know what y is in terms of x because that point hits on our parabola. So we can go ahead and say a equals 1/2 times 2 equals x times y. And this is why a few of you guys got confused when you saw in the answer key that the area formula was 9x minus x cubed. That's what happens when we plug into 1/2 base times height based on our picture. Now our goal is to maximize, and in order to maximize, what are we going to do? What do I have open? Just waiting for us to use.
Calculator. So, has the thing.
Thought I had it
Trace.
open. You have it open? Yes, you did. Okay, we can find a maximum. Maybe he's still not open. Come on. Okay. We can find a maximum on our calculator. Let's use our tools. Because we don't know calculus, we can't find the maximum of a cubic function. We can find the max of a quadratic by using vertex form, completing the square, but not of a cubic. Not without knowing derivatives. Let's get our calculator up. Come on, let's go. Okay, let me get out of the honors pre-cal parametric mode. We get into our function mode. Let's get rid of that. And we have, help me out guys, keep me honest, 9x minus x cubed. Is that right? Okay. Is there a max? Dun, 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 dun. There he is. Let's see if my window's good enough for me to find him. We can use the maximum feature, which is number 4. We can go a little before. We can go a little after. Dun, 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 dun. Now, how do I use this answer in order to be able to answer my question over here? If we can sketch this graph so we have a version of it on our notes. Somehow goes down and then goes up. Say that my graph is very small, but that's okay. And then the max when x equals, what is that, 1.732?
Yeah.
Now, my calculator says y equals, but what do I have to remember in context of my problem?
Y is the area.
Y is the area. So I can go ahead and come back and say, oh, that's right. I let area equal y1. So to answer my question, I can say this triangle is going to have a maximum area of 10.392 units squared. I don't think we're necessarily measuring inches or centimeters or anything like that. When or at x equals 1.7. value of x, check, and find the area. Check. We get with number 11. So recap the process. Graph him, put in your triangle, think about an old-fashioned geometry formula. Come looking at your x and y and say, how do they correspond, how do they relate? Plug it in, go to your calculator, find the max, and you're done.
Okay, so you have to put the x in your answer.
Oh, because the problem said find the area and the x, find the value of x that maximizes the area. So it wanted not only the area but the x also.
So it just said find the max and area.
Then you could have stopped right there. I'm just trying to interpret for you guys what those numbers mean. Okay, I guess we'll move last night. Let's stop there because number 13 was bonus and it was the volume one that we didn't finish yesterday. I would love to give you guys pretty much the rest of the time to work. There was that one example that we didn't get to finish. If you guys want to check it out, it could help with number 13. I kept working after class. I let you guys know that I was going to go ahead and set it all up. And that we had a cylinder with an old-fashioned volume formula from geometry. I had to look at my x and y and see how it corresponds. 2x was the height of the cylinder, y was the radius of the cylinder. So I plugged in, I went and got y squared from the original formula, plugged in, went to my graph and find the max. If you guys want to check that out, that will help for number 13 if you want to try and meet that challenge. Number 17 is probably a little bit above and beyond what most people do. Alright, cool kids, let me show you your review. I'll get this back up on the screen as soon as you guys are able to write down the test review. What is the one section from this book that is not in your book? Sorry, this one section from the chapter that's not in your book. Okay. So, will this test review from your book give you 12-3 practice? So what do you have to do for section 12-3? Go to your notes. Go to the figures and the pictures and their names. How to show the spins, the rotations. And go to your homework. For reviewing section 12-3, once again, you're not going to get a review for these problems. It's not in our book. It's not there. It's great for having you start visualizing some things and we'll show you the calculus. If you ever need to go there. But it's not in our book, so once again, first of all, make sure you look at your notes, study the names of the different shapes, different types of ellipsoids, and know that on the test, for sake of time, I'm not going to make you graph, for section 12.3, I'm not going to make you graph a parabola or an ellipse or a hyperbola first. I'm going to give it to you. I'm going to ask you to spin it around a certain axis. I'm going to ask you to name it, and then you're done. So I'm going to give you the conic section to begin with. It's going to be unlike homework. You're not going to have to get the shape first. I'm going to give it to you. But I'm going to ask you to rotate it about a certain axis, whether the axis of symmetry for a parabola, a major or minor for an ellipse, a transverse or a conjugate for a hyperbola. And you're going to have to show me that rotation arrow. Show me which way you're deciding to spin it based on what I ask. Give me enough in the picture that I know you have the right idea and be able to name it. Okay? Besides a problem like number 11. It's going to be at the very end. Besides that, kiddos, what are formulas that you need to have memorized for tomorrow? Standard form starting with? What was the formula from section 10.1?
Parabola.
No, that's inclination. Whoever said that was right. M equals tangent of theta. But there was also angle between. How do we find the angle between? I just said angle. How do we find the angle between two lines? M2 minus M1 all over. That's an absolute value set equal to tangent. I think those are the important ones for 10. For 10.2, that's where parabolas came in. Help me out with some important parabola formulas. Yes, I'm making you a cheat sheet that you can send me tonight.
Oh, shoot.
Can we use it on the test?
y minus k squared.
No, we said
But the square's on this side though, right? And the 4p is over here. Or, what's the other way this formula can be oriented?
1 minus k 4px.
The other way it could be is x minus h squared equals 4p y minus k. Now, do you guys still have to know how to use p to get the focus? Yeah. Know how to use the formula. These are the different orientations. Yeah. P, whatever sign it has, the normal P is going to go either up or to the right, down or to the left to get the focus, and the director sees P in the opposite direction. Remember, the focus is a point, the director is a line. So guys, even though these formulas are the basis, you have to know how to use them in order to get your focus and directors. And sketch if you need to. Section 10.3, we got 2 ellipses. So there were more formulas in 10.2 if you don't know how to get to a focus or a director, it's using a graph and visually moving to the right or to the left or to the up or the down. 10.3 though were ellipses, and we had, let's see, yeah, x could come first. With A. Ellipses always have a plus, 2 different squares with a plus.
Are we going to be able to use our calculator? Or is there going to be a calculator and not a calculator?
I mean, you can't really use a calculator.
We'll talk about the calculators. Let's get the formulas first. So we have x minus h quantity squared over a squared plus y minus a squared over b squared equals 1. That could, this one would be where a, the major axis is on the x. So if the bigger measurement is the x, that would be the a. The other version of this one would be if y had the bigger one. And Nathan is already talking about the focus, and we haven't done that one yet. This would be if the vertical is bigger. And to find the focus, you do need the foci, because there are 2 of them. C squared equals, it's held within, a squared is the bigger one, so it's a squared minus b. But you also have the eccentricity formula, right? C over a, not a squared, just a. Last but not least, we have 10.4. Hyperbolas. If the x1 comes first, then it's going to be a horizontally oriented hyperbola, right? We're going to start from an HK. I'm going to draw that because HK can shift it around. You're going to start from the center and you're going to go out A. You're going to go back A. You're going to have your hyperbolas. Remember, you're going to use B. Your asymptotes. And then whatever you have going one direction is going to be the opposite for the other direction. So the slopes of our asymptotes on this one, M would equal plus or minus B over A. The other way of writing it would be, what if the Y one comes first? And the X one comes second? It's the Y one. In the center, we're going to go up A to a vertex, down A to another vertex. We're going to go over B plus or minus A and B. I think the only thing we haven't talked about is this kind of close. Eccentricity plus C. For the foci. For hyperbolas, the foci are outside, so you're going to need C squared equals A squared. Those are all the formulas. Once again, some of you might want to look at some of the other formulas, some of those other charts that help you with the foci, exactly how to get each of the little points that you're looking for. Along the major axis for an ellipse. Along the transverse axis for a hyperbola. Outside for a hyperbola. Inside for an ellipse. So that's the foundation of it.